So before we talk about effective learning, we have to decide what is learning. And that could easily be a 25-minute talk in itself. So for ease, I've used this definition by Dale Shunk, the educational psychologist, which basically says that learning has two prerequisites. First, it has to result in a change of behavior in some way that has to last some duration of time. And that has to be the result of some kind of learned or practiced experience. Now, that could be conscious learning or something completely unconscious that we're less aware of. So learning is predicated on memory, and broadly we can divide memory into two types: explicit or declarative memory. This is things that we know we've learned, we're conscious of them, or implicit memory, things we've learned that we might not be aware of. When we talk about teaching, we tend to focus more on explicit memory, but we can also leverage implicit memory too. So declarative memory can be divided broadly into two types. The first is episodic. This is personal memories, where you're reliving an experience you had. So you're remembering a holiday you went on, or something that happened to you personally. That could be something that happened in a virtual environment as well. It doesn't have to be in the real world. The second is semantic memory. That's things like facts, figures, the fact that Paris is the capital of France. It's not something you've personally experienced, but it is something you remember learning. So you could think of that as kind of rote memorization. Implicit memory can also be divided into different types. The first would be procedural memories. This would be things like playing an instrument, learning to swim, perform surgery, or ride a bike. This is what we think of as muscle memory. Conditioning, so the quintessential example of conditioning is Ivan Pavlov, who trained his dogs to associate one stimulus with another. That's what we call classical conditioning. So he would ring a bell when he fed the dogs, they learned to associate food with the sound of the bell, and they would then salivate whenever they heard a bell. And then finally, priming. This is where one learning experience can result in a change in behavior thereafter. So a great example of this is there was a study where students were given a crossword to complete. And there was a control group who weren't primed with anything. They had random words. And then an experimental group who were primed with words associated with old age. The crossword included things like the word wrinkle or retirement. And what they found was the students primed with those words actually exited the study area and left the building more slowly than those that were not primed. This is a somewhat controversial topic of whether this is actually effective or not, but it is certainly a type of implicit memory. We're certainly not aware this is happening. So how can we leverage this knowledge of memory and the different types of memory to teach as effectively as possible? Well, one very popular framework in education is the VARK system. This is a system of learning preferences. So you may have heard this before. We say that people tend to prefer being a visual learner, an audio learner, a reading-writing type of learner, or kinesthetic, which means using your hands. So if you're someone who learns well from video or from images, if you remember where on a page you saw something, or you color code all your notes, you might be a visual learner. If you prefer hearing someone speak or talking about it yourself, maybe a group discussion, maybe what's called sage on a stage, so that's what we're doing here, where we put one person on a stage to talk to everyone else, that would be audio learning. Reading writing is fairly self-explanatory, so that might be writing notes, bullet points, or synthesizing literature. And then kinesthetic would be doing some kind of hands-on activity. So in the classroom, that would maybe be building something out of popsicle sticks, or maybe doing a lab experiment. The problem is that empirical evidence suggests that although people have a learning preference, teaching someone exclusively in their preferred style doesn't actually result in better retention. In fact, the vast majority of people are multimodal learners, which is fairly intuitive if you think about it, because it's very dependent on the content that you're teaching. If you're learning algebra, it's very difficult to teach that in a kinesthetic way that's actually relevant. And if you want to learn to swim, then reading about it really isn't going to help you. The other problem with the VARK system is it leaves out other forms of learning preferences and learning theory. So these are kind of more recent frameworks. Embodied learning is the theory that using your whole body in an interaction really embeds your learning and allows you to retrieve it more effectively. So this would be using your hands or controllers or maybe your whole body to interact with something. And this is where VR can really shine. And also affective learning, which is the theory that an emotional response will increase your retention of an experience, particularly an episodic experience, which makes a lot of sense. If you think of your strongest memories, they probably have strong emotions attached to them, whether that's joy or grief or fear. If you're kind of emotionally motivated, you're more likely to retain information. And it's also more likely to result in a lasting behavioral change. That can be really powerful if what you're teaching is something like empathy or behavior change or maybe attitudes to climate and eco-friendly behavior. So VR really shines when it comes to embodied learning and effective learning. Now, I think it's really tempting as a VR developer to just put everything in VR, but I think we have to resist that temptation. You have to ask yourself, what is VR actually bringing to the table? Why is it better? What's the value add? And is this the best type of content to teach? Is it the best tool? So some content is really highly effective in VR. The first is spatial content. Anything with a 3D element innate to it. Maybe that's anatomy, maybe astronomy. A 3D learning medium obviously really benefits the user because they can actually see these interactions taking place in a way that a book or a video really wouldn't reflect accurately. The next is procedural, so tapping into that motor memory. If it's something you can recreate in VR, then it is a really effective way to teach. And it can actually be more effective than real-life hands-on activity because it's replicable. So you can ensure that every student has the same quality experience, whereas in a lab, you can't necessarily ensure that. It's also very logistically difficult. It can be expensive. It can be quite impractical. So with procedural memory, you can do something repeatedly again and again and ensure every child or every user, whether it's an adult or a child, is having that same quality experience. The next one is dangerous scenarios. So this really taps into that effective learning and teaching with emotion. So things like fire safety training or hazard response can be really effective in VR and obviously very difficult and impractical to do outside of VR. Empathy-based training is really powerful as well, whether it's diversity, inclusion, or mental health awareness. And also situational and soft skills, because we have a sense of presence in VR that we can leverage. If you want to teach public speaking, you can simulate that in a very safe and repeatable environment where that person kind of feels safe and controlled. You can manipulate the environment more easily than you could in the real world. However, some content is less effective to teach in VR. So factual and declarative knowledge can be very challenging to teach in VR. Things like historical dates or definitions. Studies show that if you're reading something in a book versus reading a book in VR, the retention rate will be lower for the VR book versus the real book, which makes a lot of sense because the user has additional cognitive load. They're trying to understand the control schema for VR. So I would say in that example, there's not really a value add. I would add some kind of actual experiential aspect to the VR interaction. Also text-heavy and abstract concepts, so things like theoretical maths, it can be very difficult and challenging to teach in VR, maybe not really as applicable or relevant. For obvious reasons, pen and paper subjects, if you're doing long division arithmetic and you're writing something down, you're really best off teaching that with actual pen and paper. And also symbolic formal reasoning. So for any of you that code, I've been asked many times, do you code in VR? My answer is not really, because I don't really see why I would do that. I'd just be looking at a 2D monitor in a 3D headset, and that's just additional cognitive load that I really don't need. So that said, if you have content that you really are dead set on teaching in VR, there are tools that you can use to ensure that the retention is as high as possible. This is relevant whether you're teaching game onboarding or whether you're teaching educational experiences. So I've used some game onboarding examples here for any game devs in the audience, but this applies equally whether you're in the education space. Most people globally have used a computer before, so they're used to a monitor, a keyboard, and a mouse. You can assume most people have tried that input schema and have experience. But most people globally have not used VR before. I think it's really easy to forget that we do live sort of in a bubble in this industry. So unless you know your audience very well and you're certain they have used VR before, it's generally safe to assume they haven't, which means you're teaching them the control schema, what is possible in the world. Are you using controllers? Are you using hand tracking? And a lot of that depends on your content. Are things interactable? Is there physics in your interaction? Can you put in place? Is there gravity? That really depends on your choices as a developer or content creator. So it's really important to have very simple control schema and introduce them very clearly to the user. Try and avoid text UI if at all possible. If you have to have it, make it very minimal, very clean, but people generally don't read signage. So if you can introduce stuff in a more situational way, that is better. I'll give you a few examples of that. So Beat Saber is a great example of this if anyone's played it. The control schema is incredibly simple. You have these two controllers. You can move them around. That's basically it. There's kind of no buttons. And the way it's introduced to you is you have these swords, a block comes towards you and it has an arrow, and you chop one block. And from there, that's kind of the main mechanic. After that, maybe you move around a little bit, but it has this fantastic onboarding because there's no words involved. You just kind of intuitively understand it from the very, very simple mechanics. The other thing they do is they chunk information. They introduce one mechanic at a time. So chunking comes from a study which is called the magic number 7 plus or minus 2. Some of you may have heard of this, which theorizes that we best remember about 7 pieces of information plus or minus 2. But what that information actually is, so how big those chunks are, can change depending on what you're teaching. So I'll give you an example. I'm going to do a chunking demo. I'll give you 5 seconds, and I'm going to show you 20 letters in order, 20 seemingly random letters. See how many you can memorize. I'm only going to give you 5 seconds, so I'll be shocked if anyone gets all of them. You ready? Okay, here we go. Okay, who remembered all of them? I'm hoping no one has a photographic memory and it's going to show me up here. Okay, good, nobody. How many do you think you remembered? Maybe 3, 4, 5? I can see some 5s. 5's quite a lot of 3, 5, lots of 5s going up. Okay, so 5 is about right. Magic number 7 plus or minus 2. It's about 5 chunks. I'll show them back on screen so you can check if you're right. The reason that's difficult is it's 20 chunks of information, 20 seemingly random letters. But if I rearrange those letters, I bet if I give you 5 seconds, you can probably repeat them all back now. And that's because now it's only 5 words. It's still 5 chunks of information. It's just the type of information changed. This is also why chess grandmasters find it much easier to memorize a board, because for someone who doesn't play like me, it's just random positions. For them, it's just one chunk of information. It's just one position. It probably even has a name, or it's a tactic that they would use. So chunk the information. Teach one thing at a time, if at all possible. The second tactic is to embed learning in context. So start with why. Why are you teaching this? Why is the user doing this? Where are they? And what activity are they doing? Another way to think about this is to show the door before the key. So show the problem, show what the user is trying to achieve, and then give them the solution so they understand why they're doing it. One common complaint with kids learning maths is they don't understand why. They don't understand what it applies to. So give them context and they will learn. They'll be more motivated and they'll retain it better. Make sure the environment they're in virtually is relevant to the task at hand, and let them learn by doing things. So this is a game called What the Bat, and the introduction to this game is fantastic. You just have a bat, there's a trophy, and you whack it. That's it. Then there's a ball, and you whack the ball into the trophy. That's it. Then there's no ball, but there's a button. So you press the button, the ball appears, and you whack it into the trophy. And then you're off. You've learned all the control schema. So it's great. You start really, really simple. You chunk it in 3 times into information, and that's kind of all the mechanics in the game. And it's very obvious what you're doing. You have a baseball bat. You're in a baseball diamond. So the context kind of gives you a clue of what they expect you to do. You are allowed to hit things. If you're in maybe a museum environment, you might be less inclined. The third thing to do is to allow safe failure. So try and anticipate what your users might try and do. Throwing things in VR, people really love doing, particularly kids, and hitting things with sticks. So if you give them something like that, anticipate they might try it. And if you can, try and create a response in the environment that indicates whether that's what they're supposed to do or not. Not a big X on screen that says, you fail, that's wrong, but something fun and playful that encourages them to experiment. So this game is called Vacation Simulator by Alchemy Labs. I think they're really the masters of these playful interaction design. And in this game, you can take food, you can bite it by putting it in your face, you can turn it into a waffle, you can grill it, you can burn it, and you can combine all these things together. So are you supposed to do all those things? Not really, but you're experimenting, it's fun. So they really anticipate kind of all the things the user might try, and all of them have a creative response. This also shows that you should try and use objects for interaction over UI. Try to avoid text on screen if at all possible, and indicate to the user what they should be doing, using the objects around them. So you can really remember the pillars of effective learning in VR using this mnemonic, which I call SPACE. I've covered some of this already. So first, keep it simple. Make the interactions as intuitive as possible. Make it easy. Make it inclusive. Assume people haven't used VR before. Second of all, give the user prompt, immediate feedback. So if they're reaching towards an object and it's grabbable, maybe highlight it in a color. Once they do grab it, make it react. If it's possible, give them both audio and visual feedback. Make it as accessible as possible. That takes us to A, accessibility. Something we have to consider in VR is the user's comfort. Don't put the user in stress positions. Think about where they're looking, where they're reaching. Try and think about people with different access needs and different mobility needs as well. Consistency. If you're producing many experiences, make sure they're consistent. If you're able to grab and throw things in one experience, users might take that knowledge over to the next one. Also, try and keep it consistent with the real world, if at all possible. If you see an object, you probably expect it to respond in the same way that it does in the real world. And then finally, engaging. Make it playful, make it fun, and allow experimentation by your user. So how do we do all these things? Well, one way we can do this is with affordances. This was a term coined by James Gibson in the 70s and popularized by Donald Norman in the 80s. Affordances basically mean the things you can do with an object. When Donald Norman popularized this term, he actually came up with kind of two words. Affordances are the things you can do, and the signifier is the part of the object or the object design which indicates what you can do. And this leads us to a term called Norman doors. Norman doors are badly designed doors that Donald Norman was really frustrated with. They're very common in England, I'm sad to say. This is where a door will have a push sign, but also have a handle. So you don't read the sign, you just grab the handle, you go to open it, and then eventually, after looking really silly, you're like, it's a push door. So that's really, really bad object design. Ideally, doors that are push should just have a push plate, and doors that are pull should have a handle, because people do not read signage. What they do see is a handle, and they go to interact with it. If you haven't read this book, The Design of Everyday Things, which is by Donald Norman, I highly encourage you to read it. Personally, I think this is one of the most relevant books for VR design ever, and it's actually not about VR at all. It's about real-world objects. But that is more relevant to VR than a lot of UI and UX, which applies to 2D and 3D interactions. So where you want to be in this is correct rejections and perceptible affordances. So you can perceive what you're able to do, and you correctly are able to do it. Or you don't think you can do something and you can't, that's correct. If you think you can do something and you can't, that's a false affordance. So that can be frustrating, sometimes it's unavoidable, but if you can create a playful interaction to say to the user, no, sorry, not in this game, then that can be fun too. What you really want to avoid is hidden affordances. This is where you can do something and you don't realize it, because the user can then become completely stuck and actually not able to proceed in the content. So make things really clear, really visible, and really obvious to the user. So I've got some examples of affordances here. This is a UI affordance example. Both of these come from Meta's interaction suite. So the first one is radial buttons. So this is really interesting. It's kind of a combination of 2D and 3D UI design. And that's because using this little joystick and pulling it out in 3D and moving it gives you much more fine interaction. Using hand tracking in VR, if anyone's done it, can be quite challenging because sometimes users don't have that very fine interaction. So this is a really good example of great UI. And then on the right, you'll see the little widget between the fingers. So as the user goes to close their fingers, the widget gets smaller, and the edge around the fingers, you'll see it kind of goes brighter and brighter white. When they close their finger, the widget in between goes bright white, and the highlight around their hand also goes bright white.